In this video, I'm going to show you how to solve the ALEKS problem called predicting the reactants or products of esterification. I've seen two different versions of this problem. This version is the easier of the two. This is giving us two reactants and it's asking us to predict the product, and we know for sure that this is an esterification reaction. So that means this is a carboxylic acid and an alcohol coming together to make an ester. Now, I think the easiest way for us to predict the product of this reaction is going to be to draw the starting materials. So I'm just going to redraw. That's my first reactant, and my second reactant, I'm going to redraw that over here. And this is a reaction that occurs, this esterification reaction is a reaction that occurs between the carboxylic acid functional group of one molecule, so I've got this highlighted, and the alcohol functional group of another molecule. So I've got it highlighted over there. Actually, that's a little too much. I'm just going to highlight. No, I'm going to highlight the whole thing. There's the alcohol group right there. So this reaction occurs between these two functional groups, which I've highlighted. And in this reaction, these two functional groups actually need to be pointed at each other. I think it's a lot easier to visualize this reaction if I rearrange these. Okay, see, here's what I mean by those groups need to be pointed at each other. So this is where the molecule comes together. Okay, so when these two molecules come together, they do so in such a way that they overall lose a water molecule. It's one of the products of this reaction. So what you're going to do is take a hydrogen from one of these two molecules. You're going to take a hydrogen away, and you're going to take an OH away. And honestly, I know your textbook is going to say different, but honestly, it does not matter which you take from where. So let me undo some of this highlighting. You could take the hydrogen from here and the OH from here. It's going to work perfectly. Or you could take the hydrogen from here and the OH from here. It's also going to work perfectly. And again, it's totally not what your book is going to say. It's probably also not what ALEKS says, but I'm telling you, it doesn't matter how you do it. You get the same answer either way. So you are just going to pull the hydrogen off of one and the OH off of another, and then you're just going to jam those two molecules together. And that is the product of this reaction. That is the easier version of this problem. Now, the other version of the problem is that it provides you with this product and it asks you to predict the reactant. So it does not give you the stuff over here on this side. You have to come up with that yourself. If you get that version of the problem, you're given this right here, then you're going to start by finding that ester functional group. There it is, right there. And you are going to break this molecule into two pieces. You're going to break it at the ester functional group, not in the middle of the ester group, but you're going to break it at one of the ends. And you always break the ester functional group at the end that's next to the carbon-oxygen double bond. You don't break it at the end you break it at the end next to the carbon-oxygen single bond. You never break it at the end next to the double bond. So we're just going to break this molecule apart at the ester group, just like that. And to one half of this molecule, you're going to add one piece, you're going to add a hydrogen, and the other piece you're going to add an OH. So one piece is going to get a hydrogen, the other piece is going to get an OH. How are you going to know which is which? Actually, I'm going to put that back. So one piece gets a hydrogen, one piece gets an OH, and it's really important that you do it correctly. So how do you know? Should it be like the way I drew it up there, or should it be one half gets the hydrogen, the other half gets the OH? Clearly, these are not exactly the same. How do you know which one? Well, this reaction always makes a carboxylic acid, and this is not a carboxylic acid. Close, but not quite. And it also always makes an alcohol, and this is not an alcohol. Or another way to think about it is that in your products, when you're doing the reaction in the reverse direction, both products will have an OH. This one has an OH, but this one does not have an OH. So this would not be correct.